gentlemen, I stand here before you today to talk about something that contributes to 41% of Indonesia's GDP, 22% of the country's labor force, and affects all of us here today. That's right, I'm talking about industry. Oxford defines industry as economic activity concerned with the processing of raw materials and the manufacturing of goods in factories. So this includes fossil fuel extraction, furniture production, fashion apparel, and manufacturing, just to name a few. Over the past couple of years, Indonesia has seen an upwards trend in GDP generated by its manufacturing sector. As manufacturing and GDP generated from manufacturing continues to saturate, companies are placing more priority towards the efficiency and cost effectiveness of their factories. This is where retrofitting comes in. Retrofitting is the act of using new technology to keep old factories up to date without having the need to replace all their machines with new ones. Before we continue, I'd like to take everyone on a trip back in time to precisely 338 days ago. In pursuit of expanding my knowledge in engineering, I decided to visit a local manufacturing factory in London. There, I was lucky enough to participate in a tour in which the tour guide took us through different parts of the factory and explained how all the machines work together to create rows of packaging. While walking around, I asked the tour guide about what seemed to be a pile of plastic on the ground, underneath some of the machines. To which he explained that occasionally the machines would malfunction and generate packaging with slight imperfections in them. That is exactly when I had my light bulb moment. I thought, this is the perfect opportunity for me to apply the concept of retrofit. Curious, I asked the tour guide about what solutions he had already come up with to address the solution at the factory. To which he pointed at these three things at the end of the printing line. Now, before we continue, I'd like to invite everyone to play a game with me. Here are the rules. So, when everyone's ready, I'm going to put up two images that have slight differences between them. Your job as the audience is to spot as many differences as you can within a time constraint of 15 seconds. There will be a total of 2 rounds in which you have to spot the difference. After each round, remember to keep track of how many differences you spot. You may also use your camera's zoom feature in case you can't see the images. Okay, is everyone ready? 3, 2, 1, go. In this picture, there are 10 differences in which you're supposed to spot, but you're not expected to spot all of them. Okay, your time is up. Here are the differences that were in the 2 images. Now, don't forget to keep track of how many images you ended up spotting. Is everyone ready for round 2? Okay, 3, 2, 1, your time starts now. Okay, your time is up. Here are the differences. As you look through how many differences you spotted, try to think about how much more difficult it was for you to spot the difference on the second round in comparison to the first one. Now, you might be asking, Brandon, what does this have to do with anything? Well, this is actually a common solution that most manufacturing factories around Indonesia have settled for. Because the packaging is being rolled out at such high speeds, workers are forced to use strobe lights in order to actually be able to see the design and look for any misprints. Because of the nature of this solution, a lot of misprints are only detected after a significant amount of packaging has been rolled out. As a result, plastic is wasted, ink is used up, and more trash ends up in landfills. Approximately 3 to 4% of all materials used for packaging is wasted on misprint. Although this may not seem like a lot at first, the numbers add up once you start to consider all the factors. Approximately 45,000 meters of waste is produced per production line out of the average 3 production lines per factory per month. That is equivalent to about 1.62 million meters of plastic waste per factory per year. Considering that there are over 250 printing factories all over Indonesia, this number bumps up to a whopping 405 million meters. That length of plastic is enough to wrap around the earth 4 times over. This is where Lestari Vision comes in. Lestari Vision is a program that I've made that monitors the tail section of printing machines. This program is designed to stop the machine and alert nearby workers whenever it detects a misprint. In comparison to the 15 seconds that you guys had, Lestari Vision takes a mere 0.54 seconds in order to detect multiple misprints. This is where my first prototype comes in. My first prototype was simple. Its job was to do exactly what you guys were doing just a couple minutes ago. My program ran under 2 main algorithms. The first one was MSE, or mean squared error, and the second one was SSIM, or structural similarity index measure. These 2 algorithms took in image pixels as input and calculated a value that can later be interpreted as a percent similarity between 2 images. In this example, my program used a function called absolute difference from the Python library OpenCV to detect multiple differences between the 2 images and mark them with a square. As for my second prototype, I decided to solely use the SSIM algorithm as it suited my dataset a lot better. For this prototype, I used hand-drawn images and manually created data in order to test my program's accuracy. For my final prototype, I used images of common packaging templates from the internet and altered them slightly using Photoshop so that they would simulate the common misprints found in factories. I also tinkered around with the acceptance threshold so that it would only accept certain percentages of similarity. So for example, if it was above 98%, it would accept, and if it was below, it would not. I also utilized aspects from my first prototype in order to point out where the differences were for demonstration purposes. Not only does the Lestari Vision cut production costs, it also reduces the amount of plastic waste produced by misprints, saves time, and also improves the overall quality of products generated in factories. Just a 1% reduction in misprints caused by machines can save up to 54 million meters of plastic waste and 80 billion rupiah per year. If you're to take just one thing away from this presentation, I would want it to be that innovation and creative thinking is how society changes and develops. Although change can be scary at first, embracing this risk is how ultimately great things are built. As Steve Jobs once said, innovation is the ability to see change as opportunity, not as a threat. Ultimately, we all should be thinking about ways we can make the world a more sustainable, cleaner, and smarter place to live in. Thank you.